And welcome back, students. We are going to continue talking about electronics components. Let's specifically talk about electronics, and we're not going to talk completely about electronics in depth, but I do want to talk about a couple specific things before we really start sinking our teeth into what we're going to be working with. So specifically, let's talk about what electronics is. Electronics is a kind of electricity, really, in which tiny electric currents are carefully directed around much more complex circuits in order to process or store and process information. There are two different there are two very different ways of storing information. Those are typically either done through analog means or through digital means. When I'm talking about analog, this usually measures information with some kind of unit measurement, whether it be something like decibels or something like hertz. Now, until computers really emerged as a dominant force in the mid-20th century, measuring electrical current was typically done with a needle that pointed on a dial. The higher the needle, the stronger the current. Now, analog typically stored things like words, pictures, and sounds as representations on things like plastic film or magnetic tape. If we compare that to digital, digital will create and store information digitally. What this means is that some device will capture and convert the information into numbers and display or store those same numbers. And rather than using things like dials or knobs or anything like that, information is displayed on LED or LCD displays. Now, digital displays are generally a lot quicker and often easier to read than that of an analog one. And you can get a lot more precise too, because analog one, we got a little needle that moves back and forth, whereas digital one, we give a digital readout. That being said, whether or not they're more accurate than their analog counterparts depends on how the measurement is actually made and how it's actually displayed. So if you have a measurement, for example, that gets down to the hundredth of something on your digital device, it might be a little bit more accurate than the one on the analog device, assuming that that device has been calibrated correctly. Now let's talk about electronic components. The circuits inside of electronic equipment are packed with components that do different jobs, and the components are linked together typically by cables or printed metal connections. Now, the first one we're going to talk about is a resistor. Now, resistors are the simplest components in any circuit. Their job is to restrict the flow of electrons and reduce the current or the voltage flowing by converting electrical energy into heat. Like I said, very simple. They're resistors. They resist the flow of electricity. All right, the next ones we're going to talk about. First is a diode. Diodes allow an electric current to flow through them in only one direction. Diodes can be used to change alternating currents into direct currents. So, conversion from AC to DC, because a lot of devices use DC power and not necessarily AC power. Next thing is a capacitor. Simple components consisting of two pieces of conducting material that's separated by a non-conducting material. Now, a lot of times capacitors, besides store and charge, will often be used as a timing device. Then next, let's talk about transistors. These are probably the most important component in computers, as transistors can switch tiny electrical currents on or off, or they can amplify and transform small electrical currents into much larger ones. Now, when transistors are connected together, they make devices known as logic gates that can then carry out very basic forms of decision making, such as and, or, not. Next, we have optical components. There are various components that can turn light into electricity, or vice versa. It's electricity converted over into light. Photocells are one form of that, and these generate tiny electric currents that, when light falls on them, they're using various types of sensing equipment. Another common type is light-emitting diodes, or LEDs, and there's a picture of one there shown. And they work in the opposite way. They take and convert small electric currents then into light. So like I said, when they said sometimes they do light electricity or electricity into light, this is an example of electricity into light. So current flows through, LED turns on. Now, last thing I want to talk about today is, of course, the Arduino. Since we're going to be working with this device, it's good to start getting familiar with it. Now, the Arduino is an open source platform used for building electronics projects. Arduino consists of both a physical programmable circuit board, often referred to as a microcontroller, and a piece of software or IDE or integrated development environment that runs on your computer used to write and upload computer code to the physical board. All right, and that's going to conclude our notes for now, folks. Like I said, next time when we come back, we're actually going to look at the kit that we're going to be using, and after that, we're actually going to start diving into some of the different pieces with circuits. So until then,